live. So we were just talking about the robots that were displayed on the SUI network. SUI is a blockchain network. It has a lot of activity in South Korea and Middle East. Uh, and yeah, so they did a lot of the stuff similar to what we have been doing, but with robots that are like $15,000. So they were having like this unitary robots, and yeah, at least Sui seems to be all in on robots. So they also have some gaming platform blockchain related stuff, and they are trying to do also robotics on it. Uh, and that recently created a lot of buzz. So last year I had started a GitHub repo for just a white paper about what are the different possibilities we could do. There have been like some initiatives in that directions, but nothing concrete like what is possible and like concrete. So last year when I started it, there wasn't much activity, but then after this, Na has been really active on that. So we could check those two. And yeah, I also had some X402 demo. So I was able to make a demo with a fast API server endpoints, which you could pay in USDC and then access those endpoints. So later on, we could integrate that with the mini app, Eric, you have made. Let me see if the demo works or not. I'll share the screen. Okay. Yeah, this is like a simple demo I did. So it has like two endpoints, premium data and then hello world. So you pay in USDC to get this hello world JSON message payload. And then I also have like a fake endpoint which returns these JSON values: temperature, humidity, pressure, battery capacity, and Tumblr info. This is just fake, but this could be actually coming from the real robot. And then yeah, these are just HTML buttons that in the back call the endpoints I have on the fast API server. So you could just have a health check and it will return okay this. So it was basically where is it? I think yeah, this is better. Yeah, so it's returning basically this endpoint now. So when I click that button, it will return this. And then let's try hello world. So first it will, yeah. So this is what is happening. This is the fast API server logs. So first it will make a call to the endpoint, and then it will the endpoint X402 returns with the message. Okay, these are the wallet information, and this is the payment you have to make the amount. And then after that, there is one more call made with the actual transaction done. So after the transaction is done, it will send to the endpoint. Okay, I've done the transaction. Give me the data. So what the server will do is it will like go and check. So there is something called facilitator, which is basically checking if the transaction has gone through or not. So right now only Coinbase is running some the facilitator. It's like a payment verification server. So our fast API server is basically checking with the Coinbase server if the payment has gone through or not, and then if it's verified, it will send back the payload of hello world. And yeah, so we don't have to do a lot of the stuff. So Coinbase has made a X402 Python package. We can just include it and in our fast API server, and it works really nicely.
How fast is fast?
Uh, it will be whatever the underlying layer to a blockchain speed is. I would
Approximately,
say
give
like,
me a number.
let's see, maybe
One
a
second, a millisecond.
few hundred milliseconds, I would say. I think base transaction settlement is around 200 milliseconds. So the transaction actually settles quite fast. But then we have our own delays from going one server to the other. And then our own fast API server is checking with the facilitator if the transaction has gone through. So I would say, like, let's say 1 second, 1.5 seconds.
And what is the
Whatever. It would be faster than a credit card payment.
what is the fastest you think we could do?
Oh,
Two
well, if
hundred
we don't
milliseconds.
have, well, yeah, if we don't have these HTML front end, so it happens quite fast. 500 milliseconds,
So
200 to
basically,
400 millis.
are you saying also that the limiting factor anyway for the speed will be the on-chain operation, right?
So basically, let's run this on the command line and see how it works.
So this demo is what you've built.
Yeah, I built it on the weekend.
Okay. And so does it look like relatively straightforward to integrate with the mini app? It looks so.
Uh, seems like yes. Well, I have vibe coded it, so I don't understand everything. But
So does that? Okay, so that would replace Paycaster, but it can still be a mini
yeah,
app integrated on.
yeah. So right now the problem is like I'm using my own wallet, and then I have to put in the demo wallet's private key, and it's running on the base Sepolia testnet. So this, if you're doing it with command line, if a machine is doing it, then it's really fast. But I tried to build a React front end that would trigger your own wallet. But yeah, it was not triggering it properly, and then I gave up, and then I'm just doing just command line endpoint calling with the front end. But I think I checked the Farcaster mini apps documentation, and they have some hooks which you can like Farcaster has, like, when you create the account, it gives you a wallet, and there is a hook which you can like directly plug into it. So there is some wallet uh, SDK called WAGMI, and with that, it's they have straightforward examples. So yeah, maybe next weekend or after that, I will try to hook up with that. But right now, it's just a Python script with the your own private key, and then so for if it's a robot, then it's really, this is basically done for a robot, we can say. So difficult to use for a human.
Thank you.
Uh, mm, okay, this is working. So right now, there are like two. One is the server, the fast API example, and then we have like I've done two client examples from the examples given in the Coinbase repo. So one is like using HTTPX library, and the other using the request library. So like, if you do this and then specify the endpoint, and then you have to like put in your private keys and then some Coinbase. Let's say facilitator. So if you want to run the facilitator payment verification, you have to open a Coinbase developer account, and it will give you some keys, and your server has to use those keys to access the payment verification. So I've done that already, and then like if you do this, yeah, so it will first initialize your wallet, and then check the endpoint. Yeah, and then if you go to, let's see if this works or not. Let's see. Yeah, so you have this transaction done, and yeah, so this is I'm doing using the testnet, basically a testnet. So it's right now going to the same wallet, but yeah, the transaction, there is a transaction happening. So this is what the fast API server is verifying.
Cool. Are there some people on Farcaster, some of the founders are talking about the protocol? Do they plan to have something like the Coinbase integration, or and so perhaps we should wait for that, or it will not happen?
So this is just a HTTP protocol. So there is it's like the people, you can directly use it. Maybe you provide some easy hooks to like which you could use, but it's just a HTTP protocol that anybody couldn't build on. So Coinbase themselves provide Python package and some I think React front end SDKs which you can directly use. So
Okay.
right now, so I'm using these uh, X402 package from Coinbase. So they also have some fast API middleware which you basically hook into.
So they really took ownership of it, right? Because to call a Python package at the top level with a name like that.
Yeah, so it's basically this is what I had to do. That's it.
Right.
So you specify, so and when somebody calls this endpoint, it will first give a response, okay, pay to this address, and this is the network you have to pay to, and then this is the amount. So basically, in so the so there is no decimal point in let's say all these transactions. So it's like a 1 millionth is some USDC. So 0.0. So if you want to have like 1 cent payment, and then you write this, and then yeah. So this will be the first reply. It will give, first it will ask, okay, this is the payment required. And then there is a second call made with the after the payment is done, it will create a payment header for the HTTP and then send it back. And with that payment header, the fast API server basically verifies with the facilitator the payment has been done or not. And then if it's been done, it will return the payload, whatever it is. So this could be like this is just I'm sending a hello world what JSON, but it could be a web page, it could be a video. So you could basically paywall anything you want with this. And I think they also made some foundation. I think they announced it yesterday. There is something called X402 Foundation now. Cloudflare and the Coinbase have started it, but probably others are joining too.
So what is Foundation about?
Maybe agent to agent payment protocols. Let's see. Just trying to find it.
Isn't it what X402 is about?
Yeah, so Coinbase just released the protocol, but I think right now they are trying to. Where is this page?
How public is these transactions?
They are all public.
I guess that's not my question. Obviously, you can read the chain and put it together, but how visible do we want it to be?
Well, on the blockchain, everything is public.
Yes, but in order to read the blockchain, that's work. You know, it's like the difference between reading it on the news and going somewhere and seeing it. And I guess
So every transaction. So I'm using the base network,
hmm
and so basically you need this transaction hash, and they have a Sepolia testnet.basecamp.org website. If you go and put this transaction hash here, you get the transaction.
yeah, I'm trying to understand whether we want and how easy it is for other people to see what our robot is being paid to do. In other words,
Well, it's
it's not necessarily that the robot should publish it, but there could be some tool looking at the blockchain, scanning our transactions, and generating let's call it a news feed on what the robot was asked to do.
yeah,
That's what I'm asking.
yeah. That is actually some people. So there are Coinbase actually provides some sort of event hooks on the blockchain. So it will, like, you can ask, keep on checking on what kind of transactions have happened, and then if certain kinds of transactions have happened, it will send you an event back. So what you are basically saying, I think it's already possible, and Coinbase actually might actually provide some SDK for it. So there's like a on-chain event hook, something like that. I had seen something similar to that. I exactly don't know how it works, but that is something. So yeah, you could have a feed of all the actions of the robot if somebody wants to build it.
Can you reconstruct in an interesting way what the robot is doing just by looking at the payments history? In other words, the detail enough so we can do that, or maybe we want to add more information on the transaction so we can do that.
So this is just the payment log. I don't
Right, but
know
I can
what
add
kind
a
of
note,
information.
can't I?
So from the payment, we
Uh,
can just say that for a given transaction, the robot was used to do something for 1 minute, something like that, right?
Yeah,
yeah, but there should
but
be. I don't know
can we
exactly like
include a
how
note on the
underneath.
transaction,
How,
a link to an image, things like that?
yeah, that we'll have to study more. So I'm just using the topmost like SDK to do this, but there should be some way, it seems.
No, I mean, any notes, more details. What is that? More details on the bottom?
But where would you store it? Would
I
you
don't
store it
know.
on the block?
On the bottom there, it
If
says more
I'm
details.
allowed to interject.
Yeah,
Please.
sure.
Yeah, it's every time I send the two address is the same. So if you hook the event on the to address, which is the endpoint which they receive the funds, so you hook an event on that to address, I guess. So, did you set it up that? Oh yeah, okay. Yeah.
So right
It
now
should
it's
be.
the to and from address is the same. That's why it's internal transactions.
Yeah. So the two address should be sent the same even if the transaction is like public. It's
Yeah.
like from someone else. So the hook to set up there, and you scan based on that and return the newest transaction. You get the state of the robot being paid or not.
I'm really asking two questions. Question number one is, can we make the exhaust of these transactions personalized in a way that people will be able to track? And the second question is, what kind of exhaust would be interesting to have to enable, let's call it real-time tracking of the robots? Obviously, the robot can act on its own, but we care more about, what people pay it to do.
Mm.
So that's a complete service aside such kind of payment protocol, right? It's more like having a service API where we provide such kind of metadata storage and association, and that will be associated as well to some payment. But does it need to be tracked on a blockchain or whatever?
Mm-hmm. That's the whole idea. I mean, if I have a blockchain, let's put the other information on it as well.
So the thing that in blockchain history, there are some efforts, or at least they have been. I don't know whether they continue on, on really signing big data. By big data, I mean not just the transaction information, but really to sign data on the chain. And the thing
Yeah,
is
we
that
can attach.
it's a big waste, basically. A big waste. It's slow, it's costly, and it seems that personally I don't see it so much at the point, basically, because it's not really the goal. Here, the goal is to really track that what is said has been done, basically. Okay, no more than that, basically.
Well, you only tracking what was paid,
Mm-hmm.
but by looking at the robot status, which is also put on the blockchain, you can maybe know what was done.
I think that's the main point of having 8.0.4, which is the next step for the demo. Having the
So
yeah.
yeah, I don't have the demo for. So let's see.
There's someone's demo I pasted in like yesterday.
Is it
It's
in
on Discord.
the thread?
Yeah, it's a YouTube link of the last Ethereum community call.
Yeah, I was there in that call. No.
Okay, so Venkat is also sharing some ideas on the chat, huh? On
using
that.
it's for validation registry, and then you get the data hash for that. So yeah, now Bob has started validating, and this validation again, like these servers are using through AI. These are their work outputs. Yeah, so the validation score comes out to be 96. And then now Charlie has to also pay Bob for the work Bob has put into. Yeah, so as a dummy for protocol fee for Chaos Chain, will have 2.5% for every transaction that goes through it. So all of this is again like going to be stored in IPFS. Here it is. So the validation is being stored. So we have the information like metadata on it. This is the overall score, 96 out of 100. Yeah, not bad. Now, yeah, so in Chaosium, like we want to like then package all these things and then submit this evidence package to our set of verified agents. And then we want to promote like this agentic consensus where multiple verified agents will be looking to validate the output and create a score vector. Yeah, so this way, this is the workflow. And we also get our monitoring summary for what how the X402 payment was carried out. And
we're running out
sorry,
of time.
just the last.
Yes, if you could.
Oh yeah, okay. I'm finished.
You can share also materials in repo. We can also like play around if you want.
Sure. Yeah, like this is the Explorer we built, and then these are the agents which are registered here. Yeah, thank you very much. Sorry for going over time.
Yeah, so basically I was there in this call. So they had some demos, like early demos of using this. See. So this is a new ERC that is being drafted, and it's built on top of this A2A protocol by Google, and that allows a lot of extra stuff other than just A2A. I've gone through this entirely, but they had some demos related to it. So it has like a registry of agents, and then reputation, like scoring of the agents, and then what else? Yeah, so basically payment integrated with X0402 and some data management with IPFS. So a lot of the stuff we might want for our robot.
Yeah, the main thing that happened in that demo is kind of like another agent is checking the first agent's what the first agent has done. So so the state of what the robot potentially can do is verified by another agent. So the agent sees something and then sends the verification on chain also, I think.
Is that a mechanism to kind of initialize the trust?
Yes, they have to register in there's a registry for the agents. So for the start of the demo, each agent register, and then they start doing like the server agents start doing some. In this case, they did a market analysis with some crew with AI, and then the validator kind of sees the results and sees the result and updates a validation. So now the validation is public, and the state of the market analysis, so to say, is public, and some things are done. Yeah, that will prove to the client, which is Charlie in this case, that the market analysis done in okay, and Charlie then has a feedback based on how it thinks the market analysis is done. So nothing is actually like they cannot actually like see things other than process it with AI to determine whether something is done.
I think this is sponsored by Nethermind. Nethermind is a blockchain-based company, and that person who was showing the demo works at Nethermind.
How is the validator trust established? I mean, we have a validator that will validate a new service, but how is the validator itself trusted?
Yeah, it should be a validator network with validator reputation. So validator themselves would have have some kind of a reputation. So if you attack this with a bad validator, I think other validators will probably like disagree to their result, and something will happen then.
If we unroll the logic, it sounds like where we are back to certificate authorities trees, okay, of trust chains. And is that called trustless? I mean, I find that it's not decentralized, definitely. Okay.
I think anything can be a validator, or not everything, but I think the thing is that many other parties can be validators. So it's decentralized on the validator front, and as such, it is still kind of decentralized, though it is not entirely decentralized. I agree.
So what the point then? What the point over just using a central authority like I don't know, whatever? Let's encrypt, for example. Okay. Why should we trust Let's Encrypt? Okay, after all.
But Let's Encrypt, you run it by yourself, right?
Right, but it provides you some form of root certificate, or there is a trust, a chain of trust that must be validated by your browser. For example, when you hit a Web2 website, HTTPS, okay, signed by Let's Encrypt, okay. So we check the certificate, but the certificate belongs to a chain of trust, right? And that's how we know that it's legit. here it seems that I don't know. I'm super naive. I didn't look into that at all. I'm just wondering if the validator can be anyone. How do we trust
Yeah,
anyone? Okay.
actually, I don't know. I just so the first call was on 2 days ago. So we'll have
Yesterday.
to read
Yeah.
this. Yeah, yeah, how
You
this
see,
entire thing is being
And
set up.
also,
they
like,
mentioned validation. Sorry, a validation registry. That sounds like a CA. Huh?
yeah, I think that's a problem, and that's why having something physical next step will be very interesting. So, for example, if you have something physically done and you take it with, for example, a rock camera, which you might know July had made,
Yeah.
that would be a kind of a better, like more physical manifestation of what something is done and validated. There could be other ways, but in essence, like the current state of 8004 is just like it's just something that happened very recently, and they need to update on their side too. But it provides a basic framework of the flow of events that could happen and what they want to happen, basically.
Sorry, we're talking about the raw camera. Perhaps it could be interesting, Mayor, to see how they do, because you see their images, so the data, okay, are a signs. They are signed, okay, the location, so and metadata and so on. So perhaps it's related to what you wanted to talk about earlier. But sorry, I don't want to fork the discussion suddenly. So just we can come back to that perhaps later. I know it's interesting, but I have the feeling suddenly that it's there is a lot here, okay, and nothing changes in the end, okay. It's just
Yeah, the only thing in that demo, the only thing that is done in that demo, which is real, is like the market analysis done by the AI. So it is crucial for like Anurag's initiative to make a robot that does something physical in real life, so that it is actually something that has been done and something that has been verified in a good way, other than like something more than what that demo does.
okay. So actually, that would link to what Maya was asking earlier. That's something that robot does. Basically, generate some data, and it's this data we would like to have stored or signed somewhere as a proof of something was done, right?
Yeah, I think they are storing it on IPFS, right?
Yeah.
At least this demo is storing it on IPFS.
Let me close the loop though for why it's interesting. Just because you told the robot to pick a ball up off the floor, it's a real world. Maybe the robot didn't manage. And sometimes you want to pay by result, not by action, especially if the robot is autonomous. So paying for, I gave the robot instruction to pick up the ball, okay, is not the same as the robot picked up the ball. So showing what the robot did, how hard it tried, what the result looks like, is an important part of the payment itself. We're treating it as if giving the robot instructions is what you're paying for. Nobody's paying the robot to say, to get an instruction. They're paying the robot to do it. And because the robot is real world, yes, Venkatesh, could be proof of behavior, but more interesting, I believe, is proof of result.
Yeah, I kind of thought of an example back on Discord where one robot calls another robot to come here, basically, and the robot that delivers the request to come to that robot takes a picture after the robot actually comes. So for the robot to take a picture of two robots together, that will be a proof of, okay, that robot has come. If we have a before photo with a with one robot and an after photo with two robots, maybe that could like proof of outcome for the come action. That's just a stupid example what I think about, but yeah, we could have more creativity on the ways that we can prove something physically.
The ROC camera is generating some sort of ZK proof, right? That it's
Yes.
taken at some location or something. Maybe it's using some GPS coordinates to prove something.
Yeah, and if ZK proof is used, perhaps it can also apply to digital actions, where you can prove something is computed or not via the ZK proof. So if you have a hard question which no one has an answer yet, and you use you have a proof verifiable answer after the action, then it can also potentially be proved mathematically.
I think you want a smart contract that passes the money on only after the proof of outcome. Again, robots are slow. They don't do something in 500 milliseconds. Is it possible for us to do that, Anurash?
I don't know. We'll have to explore. So I've been exploring this succinct SP1 SDK. Yeah, so they provide a small RISC-V ZK virtual machine, and then you could write some circuits to prove sort of circuits in Rust to prove whatever you are doing. So I've been I don't know what I'm doing, but I'm just exploring their SDKs to do some stuff. So I tried to vibe code something so that like if the drone, so I have this DJI SDK or Tello drone, right? So it comes with a Python SDK, and then what I was trying to do is like, let's say we have a GPS, so I was taking the GPS coordinates, and if it can prove it's in a certain GPS location, then it will send, it will ask for a mission to the fast API server, and the fast API server will verify the proof and then send back a mission. So the mission was basically fly up 1 meter and then land again. So for demo purposes, and then like the drone fast API server could also verify that it's coming from a certain like server it wants from. I was trying that, but yeah, didn't get it working. But this is something that could also be tried out. And there, yeah, so the documentation, it's a little lacking of what's happening, but that is how it is. And yeah, so they also, this proving it's not, it's time consuming, so they have a prover network, and they have some token for, so you could basically delegate the proving to a network of computers, and then they have set up some GPUs that will generate the proof of whatever you want to do. So it's faster than trying to prove it yourself. So yeah, I was trying to get that also working, but yeah, it's still in early prototyping stage.
So a quick note back on what I said earlier, like validation registry in the ECR 804. Just reading a little bit, I guess what they mean is it's this kind of protocol is a stable protocol in the sense that it's not absolute trust like we would get from a certificate authority, but it's a trust over time, basically. Okay, that trust evolves over time. Okay, so it needs to be initialized somewhere. Okay, so if there is a malicious validation node, the protocol will expel that node over time, basically, as the reputation will go down. Okay? I just don't know how it works, but it looks like it's something dynamic like that. And so if it's something like that, basically, then it's decentralized, yes. Okay. And so, and there are all the pathologies about what is true and what is not true then, huh? Okay? That can happen on a decentralized network like that. Huh? Very, very curious about how they would do it and offer guarantees that guarantees like nothing bad can happen or that eventually something good will happen. Properties, basically.
Eventually.
Yeah, you know how people in logics work. Okay, so they speak funny. Very interesting, and thank you for sharing all that, by the way.
Yeah, and then now I started a small repo and a notebook, LM, no, to just explore the things we have. So basically, where is it? Where is the repo?
I was thinking, Mayor, what you were saying earlier. Like we ask something to robot to do something. Okay, so why don't we just record all the sensors what they're doing? So in a time series for each sensor, and store that somewhere like IPFS or whatever, something more modern. Okay, and link to the payment hash. Okay, and so why not? Okay, but the problem is that even for a simple robot, with just 2 motors and maybe one sensor, whatever. Okay, so like the tumbler. Okay, even simpler. A minute of
A huge amount of data.
sensibly sampled data is already very big. See,
Right.
yeah.
You know why it is?
Sorry?
Because you're taking all the responsibility away from the robot. Okay? The whole idea is I have an autonomous robot. It should be autonomous in carrying out my instructions and autonomous in proving to me that it carried out my instructions. So if the robot puts 1 gigabyte of information out for every instruction it gets, it's not being autonomous.
Right.
And that's why I asked, what is a useful amount of information? But there's no question in my mind that the robot is responsible for deciding what that useful information is. For example, if it was pick up a ball, useful information is maybe a picture of the ball being up in the air. That's it.
Yeah, so aren't we talking about a smart contract then? And so the problem is then how to link the smart contract's input, but most likely output, to the real world, right?
Here's a question. Who is supposed to define what's in the smart contract? Is it the customer, the robot, or us? Let's take the example of pick up the ball.
It's very likely a Venn diagram with the three at the intersection of the three.
No, it's not. It's not. That's what I'm saying. From a practical perspective, usually you don't want to have all of these things happening. You want to have the default be that we have defined ahead of time what is a possible outcomes you can ask for in a contract, some sort of language, protocol, whatever. There should be rare cases where the robot can say, I didn't meet your outcome, but I did do what you wanted, and let me prove it. You see, the ball's not here, it's there. Maybe I kicked it and didn't lift it up. And there should be, I think, even rare cases where the customer defines what an allowable outcome is. And the reason why I don't trust the customer is because it might be very expensive and we don't know ahead of time how expensive it is. In any case, yes, it's a smart contract, but I think the question of what are the options in the contract and who's responsible for proving it's been fulfilled is an important question if we do crypto robotics. And again, I'm leading with two issues. Issue number one, the robot is autonomous, so I expect it to do more by itself. And issue number two, the robot is real world, so things take time and things are messy. You know, once it leaves the robot, it's all digital, so it's easy to do.
Mm-hmm.
So I want to make sure that the robot is able to give me an output which is as unmessy as possible so that it's useful and the roboticness is hidden to the extent possible.
Yeah, there's a concept called contract factory where there is a public factory function that creates contract of certain formats. I think that is in the robotnomics white paper. YaRG, if you have the
yeah. So actually, there is already something called Open Zeppelin, which has a library of verified contracts on Ethereum. So they audit these contracts, and then basically you can customize it for your own things. So there is already something like that.
Do they have, let's say, cyber physical contracts?
Maybe not. Right now, it's all maybe finance related.
Right?
A lot of it is just finance related, probably.
Okay, so everything is cyber. So perhaps here we're talking about something a bit cyber physical, right? It's to link to the to reality, and but perhaps it's smart contract is a generic term, so it's definitely what Maya says, something specialized to such kind of activity. Okay, the thing that it doesn't seem unheard of in the sense that if we take any software library, okay, OpenSSH or whatever, okay, or a web API, they have a well-defined semantics, okay. They define protocols basically, okay. And here it's about how to define a protocol that is flexible enough so that clients can ask something useful, but also safe enough so that the robots respects the laws of robotics, among others, okay. And also there is a mechanism to basically refuse something that is not feasible, okay. Like the robot is in New York, okay, and we say, okay, you have to come to Japan within 15 minutes to plant some rice here. It's nonsense, right? Okay. Even if the robot is mounted with rockets, basically, okay. So it looks like a specialized smart contracts, perhaps like what Open Zeppelin is offering, but for cyber physical, so something perhaps quite more complicated, right?
Yes, but what you called about laws of robotics makes me wonder, what are the 3 laws of robotics for what you just said?
So I mentioned them because they are a generic framework in the first place, okay? But maybe they are not concrete enough, okay, to be pragmatic, basically. Okay. So, for example, let's take the example of this robotic with rockets. This robot in New York with rockets who would come to Japan to plant rice. Okay. Well, perhaps by being really abusive of its environment, by using the rocket max power and so on, and taking the risk to harm people around it, it could make it perhaps. And so then we have a link to the three laws of robotics. Okay. But it's not very pragmatic, okay? It's perhaps, I don't know.
I didn't mean that. The three laws of robotics are meant to regulate the interface between robots and humans.
Mhm.
And what I'm saying is, I want three laws of robotics that regulates the interface between robots and verifiable transaction requests. So it would be something like a robot will try to carry out a request unless it uses up more, unless it destroys itself, things like that. That's what I'm saying. In other words, I'm agreeing with your description of what robots, what they need to do, what the protocol needs to do. And I'm asking if we can vibe simplify that protocol by doing the equivalent of the three laws of robotics. Okay, robot will do what it's told to do, a robot will prove. I'm not sure what they are, but it seems to me like you can define a small number of rules, which means that you understand how robots are supposed to react to your request. And that's what I meant by three laws of robotics. Not humans, not part one Mars. There's no humans.
Mhm. So I hear that as at least something like a refinement, more pragmatic approach. So yeah, I agree. Okay, just right now I don't see anything that is really convincing to deal with that. No, that reminds me a science fiction book where there is a robot at the beginning of the book. This robot is at home. It's a kind of butler robot, and this robot kills the owner of the house. Okay, and the whole book
Yeah.
is about that. Okay, and
Yeah.
I don't want to
Wait,
spoil.
and leave the curtains open.
Sorry,
That was the point. The robot left the curtains open.
but no. Well, that's part of the discussion. Sure. Okay. But I don't want to spoil the book. But if I don't spoil the book, I can't make my points. No, I feel ridiculous now. How can I do? Can I spoil the book? I didn't give you the title anyway. Okay. Um, yeah. So okay. So sorry, but the point is that there is a reason why the robot kills the owner. Okay, and it's completely unrelated to the robot and completely unrelated to the owner. And without spoiling anything, I will say wireless. Okay, just something happens on the in the air, and the robot performs that action, that unfortunate action that kills the owner. Okay, and so sorry now. I'm confusing myself. I wanted to link back to so how to have concrete laws of robotics in this context for me is something that is worth discussing, but I don't have a good idea right now.
Yeah. So yesterday, now I've put in a lot of effort to make this. Let's see.
No,
Share my
it was not.
screen.
It was always always the model's effort, not mine. And I think the creativity that needs to like make the rules, the robotic rules inside the contract is kind of undecided right now, which is why
Yeah, so basically we could use this repo as like the things we want to do, or what we think is possible. And then so I started it just randomly last year, and then was trying to put some links in it. So what we could do is basically, if we want to implement, let's say, X402 and 8004 ERC804, then we could have a section and then a related Tumblr implementation of it. So basically, you could have like somebody could read this, and if they want to implement something, they could just go and see the Tumblr part for it. So this could be like a big map of the things we want to do.
Yeah, we obviously need more protocols here. It's only
Yeah.
just 3 protocols right now, and the actual final deployable thing could be like 30 protocols.
Yeah,
We need
so
a
it
lot more
will
protocols.
require. So this will require some. It could be like a living document. Whenever we know something, we could just add a section there. Okay, this is the protocol for it. Let's say if a robot needs this Ethereum attestation, so we could use those protocols and then try to implement that on Tableau, and then have some sort of like a living document in this repo. That was the idea. So yesterday, Na and I were working on it. So I started a notebook LM document, put a lot of documents here, and it generated some sort of comparisons of the different protocols and what is possible. Yeah. We have 2 more minutes left in the meeting. But yeah, I will try to make that work, X402 work with the mini app you have, Eric. I haven't had time to merge your PR, but I'll merge that and try to integrate the payment endpoints there.
Perhaps something I could do is first, to if we accept that my branch on the mini app becomes the main, okay. If you want, I can tidy up a little bit. I mean, everything, merge the branches and so on, verify they work. Maybe I already did, by the way.
I think you already did that. So I haven't had time to like merge it, but we can. I can merge it this weekend, and
Okay.
then we can check. So if you want to play with the payments, you can check the YaRG SDK, and then I think Farcaster the wallets directly integrate with that.
But
So Farcaster already has wallets integrated, so it's
right.
easier there.
And so, but please keep in mind that that's the only part that is missing right now in the mini app. I didn't go back to that. Is access to the mini app user wallets. Okay, so supposedly when the mini app is started in Farcaster or in such kind of context, okay, the SDK, the Farcaster SDK, is supposed to have access to the FID, okay, to the user ID, okay, and I don't seem to be able to get it, okay. So that's why Paycaster is optional basically, because if the FID is not found, then right now it's free to use. Okay, so assuming there is something online.
Yeah.
Okay, and so the thing that replacing Paycaster by the X402, you still need clients or a user ID. Okay, whether it's a wallet ID or an FID or whatever. That I haven't figured out yet how that works.
Okay. Yeah. Actually, I had figured it out last year. So there was some Python a library that allows you to get FID from the username.
But that was before. That was before the move to mini app. So it's a completely new protocol.
Okay. Okay.
So that's why what I talked about earlier is based on the documentation. Okay, and I think it's really clear, really well done. Okay, I just didn't figure out how to make it work completely. Okay, supposed to, and the thing that anyway we were very early working on mini apps. So the documentation was already there, but it was a bit all over the place and stuff like that, and it's evolving step by step. So perhaps now it's much more. It's clearer on how to do and how to get what we need. Okay, so
Okay.
It's something I reported on in August. Compared to June, a lot of the tools to help you develop a mini app are maturing and easier to use, less buggy and stuff like that. Okay, so perhaps we are good now. Okay, it's one thing. Okay.
Yeah, one thing in the call for 8004, which I was in, so they have this hackathon going on for the next 2 months until Dev Connect. So basically, if we build something with 8004 integrated with our robots, basically we could like demo it with them. So they have some ongoing hackathon for like the next 2 months.
Let's please tell me
Yeah.
on Discord if I can help. Huh? For
Yeah.
me, the past recently I'm working on the Tumblr simulation. Okay, and so good news is that I managed to make the Elegu code work with the simulation. So unfortunately, it's the behavior is strange, so it's not self-balancing properly. Okay, it's jumping. Okay, so
Yeah, and you will need the PCB, right? Yeah, I will send it.
yes. Oh yeah.
Yeah.
There is also that, and we have the payment to sort out for the PCB as well.
Yeah. Yeah, so it's here, right?
Shiny.
I haven't I haven't thinking like not put it on the Tumblr yet, but yeah, all of it works now.
Great. Yes.
Okay. Then see you
And
next week.
nice to meet you now and talk to you soon.
Yeah.
Thank you. Good week.
Nice
Good night.
work.
Bye.